All right, guys, we're going to take a few minutes to go over the text notes of our new chapter on gravitation. Earlier this week, you guys have been investigating this stuff mostly in concept. Had some of the physicsclassroom.com tutorial and some concept builders. Now we're going to get into it a little more mathematically, but you should hopefully recognize this formula if you've been doing the assignments. So anyways, section 12.1 is all about Newton's law of universal gravitation, which really is this equation. And the concepts you should have been hopefully grasping up to this point this week is that universal in this law means just that, kind of everywhere. And specifically, any two masses in the universe have a force of gravitational attraction between them. Even if it's very tiny, it's there. So for example, any two people beside each other or anywhere really, but let's say somebody that's closest to you right now, there's a gravitational force of attraction between you and them. Now, that does not mean you're going to fly together because of a force due to gravity. It turns out if neither of the masses are huge, like planetary or sun or star or moon huge, it's going to be pretty insignificant as far as the feel from it. You'll never notice it. But the point is that it's there. It exists. And this formula describes the size of it. Now, one quick thing we got to make sure we do is no longer always assuming that force of gravity means weight. Remember how we all said that back early in the year? The reason why we used to say that is because we learned only about the force of gravity between like us and the earth, or any objects, any masses close to the earth, near or close to the surface of the earth and the earth. In that context, the force of gravity is the same as weight. This is more universal. This is between any two objects, so that's not going to be called your weight unless it's back to the like thinking of the old way between us and the earth or something like that. So this is more of a general force of gravity between any two objects. And Newton came up with the formula. He even knew there was a gravitational constant he couldn't figure out, but he put in there, and that's big G. I want you guys to watch another video called the Cavendish experiment that I'm posting to learn a little bit more about who figured that out and how. But anyways, if we know the known mass of any two masses in the universe, and r represents their distances apart, multiplying it times this constant, which is a very small number, 6.67 times 10 to the negative 11, that will give us a force of gravitational attraction between those two objects. And like I said, if they're two everyday size objects, even very close together, you're going to get out really small numbers because you're not going to be able to feel this. But if at least one of the two masses, if not both of them, are like planetary big, star big, moon big, even if they're fairly far apart, there's going to be a significant force of gravity between them. And one quick thing on this constant big G, kind of crazy looking units right there, but really like any constants, their units are there in order to cancel out with the units in the rest of the formula to form newtons in the force. So that's kind of a quick, simple reason why they're really ugly units. All right, so anyways, I have a little note on here that might be helpful also when doing your problems. It says, refer to the table on the back cover of the text for values about planets and moons. That just means like if you need to know the mass of a certain planet or moon that's not given in the problem, or maybe how far apart some things are from the Earth as far as the R value that aren't given in the problem, there's a table on the back page of the book. In your PDF book, it should be on the last page, that has some values like this. You could also Google them as well if necessary, but you should have them available there. All right, so that's the basic concept of this formula, and it's a very important formula as we go forward, especially with figuring out how and why things orbit, and we'll get more into that later. The next video, other than the Cavendish one I mentioned, will be explanations of the examples in this section. So please watch those before you move on to the problem.